All right, started the broadcast right now. We were just discussing when people were taking the test, and Adam was talking about what we were having difficulty with topics. I'm about to share my screen. So pretty much this whole chapter for me, because I have absolutely no hands-on knowledge. It's all been textbook. And that's pretty much it. Like more the advanced stuff too. It's just I don't deal with it at all in my day-to-day job. So that kind of puts me back a little bit.
Okay.
So I don't know what everybody else's opinion of it is. If it's the same or other things, guys, feel free to chime in.
For me, I think it'd be the security aspect of some of the stuff you got to do with the configurations. But I don't know. I mean, in Network Plus, I think you just got to know a lot of the show commands and stuff like that on routers.
Yeah.
And so I think having
well, and it's not all going to be routers, right? I mean, there's going to be a fair portion of it's going to be switching and that sort of technology. Let's see what we can put together.
I guess when we're looking at this, so 3.3, where it says given a scenario and implement network hardening techniques, I guess maybe kind of dive into that, because the other two are just, compare and contrast. So that's just, basically studying the textbook side of it, whereas this is more the troubleshooting and probably the stuff that's require at least a little bit of hands-on knowledge.
So, I mean, the host base or the anti-malware software, that, I mean, you've dealt with some of that at least, right? That's not terribly mystical. The host base stuff especially is, I mean, it's like AV. It's the traditional type of software. There's Black Ice. There's 500,000 endpoint security software platforms. That's basically what we're talking about there. So cloud and server base is a little more mysterious, but at the end of the day, it's just a appliance that you forward traffic and logs to, and it alerts based on that information. Network based is typically an appliance, although a lot of the cloud-based stuff is sort of hybridized network-based because it's got some sort of software agent that consumes network traffic off of mirrors and things like that. Am I speaking Greek at this point?
No, not really.
If I'm speaking Greek to anybody, stop me now.
I think I'm following you.
Okay. So, switchport security. So basically there are, this all gets down to configuration hygiene stuff in your switches. This is stuff that's easy to screw up, but if you're diligent about administering your network, you can eliminate most of this. DHCP snooping is essentially, you know how the DHCP protocol works?
Very elementary.
DCU? You said DCU?
DHCP. So DHCP is a dynamic host configuration protocol. Basically, when a host connects to a network, it sends out a broadcast and says, hey, who can give me IP configuration information for this network? And typically, your networking gear is configured to respond with, go talk to this guy. And it will forward the initial request on, and then the DHCP server responds with the configuration information that the host needs to set itself up. That's how you magically get an IP address, right? So there are ways you can connect to the network and promiscuously sniff for that and intercept it. There are protocols that prevent that on the switches. So I wonder what they ask for on the Net Plus.
Let's see if I can find it in the book.
Yeah, and forgive me, I don't have a copy of the book that you guys are studying from. I don't think, unless it happens to be in our book.
DHCP like offers a handshake or confirmation to say, yeah, you need an IP address. Yes, this is what I have available. You want this IP address? It says yes, and then it confirms and gives the IP address to them.
Right.
Okay, so initially I misunderstood you saying, I thought you said DX instead of D8.
No. Yeah, sorry. Yeah.
So yeah, understand that that's process that is held within the DHCP server that offer those IP addresses and manages all the IPs on the network.
Right, but basically, so one of the attack types is to sit there on a network and basically masquerade as the DHCP server, because if you're sitting on the same switched device, and you see a broadcast come by, your machine can respond faster natively than the configured DHCP server on the network.
Okay.
Because, and the reason for that, and this is something that you sort of need to keep in mind at all times while you're thinking about networking, is every device that you have to cross introduces latency. Okay, it's not tremendous, but it's enough. Routers have to look at a packet when it comes in and decide what to do with it and then send it. And if there's any other routers downstream, firewalls count as routers, they all have to do the same thing, right? So all of that processing time happens really, really, really fast. It's done with very low latency per packet in the device, but when you stack 6 or 7 of them up, that's when you start to see you go from 1 millisecond ping times up to 3, 4, 5 millisecond ping times. Now that 3, 4, 5 milliseconds is long enough for an attacker sitting on a network to respond to the client's DHCP request before the authoritative DHCP server can. So one of the ways to mitigate this is to go into your networking gear and say the only place you should see DHCP responses from is this port, which is your uplink to the rest of your network, right? And at that point, it blocks that attack type from occurring, because when the switch sees a DHCP response coming out of the Randy's Ethernet port down the hall, it goes, that's not supposed to be there, and ditches it.
Okay, so that's part of the hardening process?
Right. It's just a hardening measure. In terms of functionality, the other advantage is it squashes like rogue APs and things like that, where Tommy's brought in a router and gotten Time Warner Cable to hook up internet in the back and has plugged it into the rest of your corporate network.
Okay.
And I'm picking names at random. I'm not maliciously picking on anybody. All right. How do I lock it onto Sandra's view so I can keep seeing?
You just click my picture.
Gotcha. Cool. Clicky. All right. So, ARP inspection. I'd need to read the book to see what they're diving into there. However, I will. So, ARP poisoning is a thing, right? So let's talk about what ARP does. Are you guys all familiar with ARP?
Yes.
Okay.
Yes. Okay.
I
they
deal with.
actually-
Sorry, go ahead.
They actually have the poisoning labeled in the book that I'm looking at, whereas the snooping one they didn't. So let me get to it.
So, I mean, ARP is one of those fundamental networking protocols that nearly no one deals with on a regular basis because, I mean, most of the time it just works. So basically, if you want to communicate in an IP switched IP environment with anybody, you got to send out an ARP broadcast, right? Well, that broadcast is saying who has, and if you ever do a packet capture, ARP broadcast literally will say this in Wireshark: who has this IP address? Tell this MAC address, or this IP address rather, and it will respond with the appropriate MAC address so that the computer that's wanting to send traffic to the IP address that's been asked for can put the correct MAC address in the Ethernet frame before it sends it out on the wire. And it's the same kind of thing, right? Where if an attacker wants to grab all your traffic, they just respond to every ARP request from your machine with their own MAC address so that you forward all of the traffic to them, and then they can take it and send the traffic onto its destination because they can just strip the MAC address for their machine, pop the MAC address that actually should have been there in place, and forward it on. So the ARP inspection is going to allow the switch to look at that and say, this host just responded with that, because the switch has a hardware forwarding table, right? So it's going to have, even if you don't have an IP address configured on the switch and it's not acting as a gateway, it has to know where every MAC address is that's attached to it. Okay. And every switch or in every MAC address that's attached downstream of it as well, right? So when it sees an ARP broadcast, it records the MAC address of the broadcasting machine and adds it to its table. So it knows that that hardware address is on that switch port. So it can tell if suddenly this one host is responding with its own MAC address for everybody's IP address. It's basically trying to set up a mail forwarding address for everybody on the block, right? So again, the switch can inherently shut that down because of its privileged position on the network and the ability to track all that. Now, not all of this is natively turned on, right? You got to turn this stuff on.
Okay.
So are we going through these too slowly? Do we need to speed this up, or do we just want to keep plowing ahead and see how far we get?
Keep plowing.
All right. Cool. MAC address filtering is, to my mind, a bit draconian. But I mean, it's basically going on your network and saying the only host you should talk to will have this set of MAC addresses and building a table in your system to operate off of. There are other things you can do with it, like go through and filter for. So MAC addresses are broken down into typically two pieces. So there's a leading piece that is the first half of the MAC address that's assigned to a vendor, and then they basically get the entire range below that, and they can assign whatever they want to after that, right? So you can, just by virtue of looking at a MAC address, know what kind of hardware you're looking at. Well, certain vendors go one step further, and you can look at the rest of the MAC address and tell what type of, like, this is a Cisco switch or this is a Cisco VoIP phone. And different vendors do it different ways. A lot of the big vendors they don't just have one leading MAC address header, right? They got a bunch because they make a lot of hardware. So you can start to do things like, the only thing you should see on this port is a VIA phone, or the only thing you should see on this port is a Dell PC with this kind of MAC address. So you can do stuff like that to sort of block out and prevent people from joining your network. Most of this stuff is also done by upstream appliances they're Bradford, Forescout. There's a bunch of different vendors that do this, but basically what they're doing is interrogating the switch, talking to it, finding out what MAC addresses are attached to it, and then interrogating the devices that are attached to the switch and deciding which ones of those should be on your network and shouldn't. And it's all got a whole bunch of configurability and stuff you can dig into, but it all basically predicates off of the same sort of technology. All of that makes sense.
Yes.
If anything doesn't make sense, just shout or start spamming up the chat over there. So VLAN assignments. So VLANs, is everybody familiar with how VLANs work?
That is the one thing I actually deal with at work.
Right.
VLAN virtual.
It's a virtual local area network. So your switch is not just one switch, okay? Your switch is several switches. It is divided up into virtual LANs. So, and I've never been in a corporate network where this wasn't the case. Pretty much everybody has different VLANs running around. So if you've got multiple subnets, right? So you look at a host and it's got a subnet mask, right? Well, you go out to a different floor or to a different part of the building and the network part of the network address changes. It's different subnet. Very, very likely, I'm almost guaranteed that it's a different VLAN that's assigned. And basically all a VLAN does is in an Ethernet packet, when something's being sent across the wire, it adds a little bit of extra information in there that tells the switching devices on the network that, well, the switching and routing devices on the network, that this particular packet belongs to this virtual network. And the advantages to that are that you can start stacking multiple networks onto a single switch. So I don't need to put out a switch for all of my VoIP phones. I don't need to put out a switch for all of my computers. I don't need to put out a switch for all of my wireless access points. I can trunk all of those VLANs from the gateway device, be that a router, firewall, whatever, down to the switching infrastructure. And then the switching infrastructure can pass those VLANs down to the hosts as however they need to. In most environments, you'll see, in most environments that have VoIP, what you'll see is that all of the switch ports that go down to end user workstations have two VLANs on them. One of them is tagged, and that's typically the one that carries the voice traffic. And what that means is if you plug into that, your computer natively is not going to do VLAN tagging. So it sends out all of its stuff untagged. That's a tagged versus untagged is a concept in switching that you need to get comfortable with and understand. And basically all it means is, does the switch send this Ethernet frame from this host with or without a VLAN tag on it? If it sends it without, that means any device that's looking for traffic that doesn't have a VLAN tag on it will read it and receive it as you would expect, and it works just fine. If it sends it with a tag, anything that's looking for untagged traffic will look at that packet, go, I don't know how to read this, and it will discard it. That's how your computer can get a IP address, but then if you plug a phone into the same port, it'll pull an IP address on a completely different network because the phone is VLAN aware and it's got a basic switch in it. So it's looking for that tagged VLAN, and then the untagged VLAN that's passed along with it, it knows to pass to its downstream host. That's how it's configured. You can do a ton of stuff with VLANing. It's a very, very flexible way to pass networks around. And as far as network segmentation goes, things that are on VLANs cannot communicate with one another unless that traffic is routed, right? So routed, or there's a caveat to this, or someone goes and takes a physical cable and plugs into a port that's on this VLAN and clicks over into another port that is on another VLAN. That bridges them and allows them to communicate. Otherwise, They cannot communicate at all. So, what questions does that leave y'all with? Because I know I just word vomited at you.
Yeah, the communication part is only done within the particular VLAN that is set up, or
What do you mean communication part?
Well, you said they can't communicate unless they're bridged or
right. So natively, the switch will not take traffic from. Let's say I'm on VLAN 10 and you're got a PC sitting on VLAN 20. Those devices, even if they share an IP network, won't be able to communicate with each other because they
not in the
are
same
on separate VLANs, and the switch won't forward traffic between them. Now, if you put them both on the same IP network, it would get really, really weird because there's not a whole lot of devices that'll allow you to put two interfaces on the same network in the same device. That gets real wonky real fast. What you typically see is that you've got a subnet on that VLAN, I've got a subnet on this VLAN, and there has to be a router between us. So that's how you can take traffic off of many separate, disparate segments in your network and force them to funnel up to a central router that is configured the way you want it to manipulate traffic in the way that you want.
So does the VLAN help with the communication, or just provide a communication method for a smaller segment on your switch?
Right. It allows for smaller segments, right? So I don't have to have the one network that has all of my voice devices, all of my PC devices, all of my wireless devices. I can start to break those out into bunches of different. So I'll have VLAN 10 as my desktops, VLAN 20 as my phones, VLAN 30 as my wireless. Well, then the switch can take that, and it takes VLAN 10 and it can pass that out untagged to all the ports. So if I just plug in, I'm going to get a PC address. But then it knows when it sees a wireless access point that the wireless access point is going to be tagged on VLAN 30. And it can pass that tagged VLAN up to the wireless access point, and then it's got its network, and it's totally independent. Those two can't crosstalk. They've got a route to get between one another.
But it will pass it. But it will pass it on over.
It switches it over. It switches the traffic, but it won't allow them to. It won't switch it between VLANs. The switching only happens within the VLAN.
Switching only happens within.
Now that it gets a little weird if you get into like layer 3 switches, because those can actually start to act as routers. So if you configure multiple IP addresses on a single device and it's got an IP address in both segments, when you route traffic through it, it'll hit that device and it goes, oh, I know how to get there, and it passes it over to the other VLAN. May not be what you want. You have to be real careful with that. So let me see if I can find a good primer on VLANs. I won't waste time Googling while we're on this. I will send this out after the fact. VLANs, do you all want to spend more time on VLANs? Because I mean, it's a deeper concept.
I know it takes a lot of time, and it doesn't, and it has something to do with trunking and
setting. It absolutely does.
And
it's kind of like them.
I know a little about it. I just like Sandra said. I mean, I hadn't actually set one up, other than in class and school, and working environment like that. I hadn't done that, so something I look forward to trying to do, though.
Yes, Stella. That's sort of the design and how it works. That's why it's there. And the other thing is, so your router upstream, it's VLAN aware as well, and it'll have multiple. And the way most devices handle it is either they have VLAN interfaces. So Cisco does it this way. They when you create a VLAN, you create an interface on that VLAN. Well, that's the router's interface that's connected there. Then you can have many, many, many ports on that router, switch, what have you, that are in that VLAN, but the gateway router is like a virtual port attached to it. In their firewalls, it's a little bit different because the sub interface gets, or they split it out into a sub interface, because in a firewall you've only got like 8 ports, right? So you can take one of those 8 ports and you can put sub interfaces on it. Well, those sub interfaces you can do, I don't remember what the limit is, but it's theoretically as many as you'd want. There's only 4,000 something VLAN IDs that you can use because of the length of the Ethernet field. But you can define a bunch of sub interfaces, and each of those sub interfaces has a VLAN ID associated with it. Well, then when you connect that firewall port to a switch port that has also got those VLANs configured on it, now you can connect many, many, many things to a single port on a firewall. Does that make sense?
Yes.
So because VLANs are such a deep part of this, let's maybe do a follow-up session on VLANing, and we can do a little bit on like the ARP spoofing, DHCP spoofing, MAC address filtering, all that, while we're doing it. And maybe we could would you guys be able to get together in person? Maybe not this weekend because I won't be able to get the equipment together, but maybe the weekend of the 3rd and the 4th.
Yeah, I wouldn't be able to do it this weekend because I'm getting my kids.
Yeah, it's a kind of short notice.
Yeah. But I think next weekend works for me.
Okay. Well, if nothing else, we can do a web session, and I'll actually have a webcam set up so I can show you guys what I'm doing if you can't attend in person.
The 4th would be great. I mean, for me.
All right, then I'll start a group on, or an email thread on that when we get down here.
Okay.
Stella, did I answer your question? You good? Okay. Maybe she'll come back. Security policies, that's most... Okay, cool. Security policies is the most vague thing I've ever seen. What is the book talking about?
Kind of curious. What did I usually have 2 computers up, but my other one's acting up.
Okay.
I need to go watch Professor Messer and see what he has for that. Because the nice thing about him is he'll go through each of these bullets, and it's almost like he kind of covers things that I have 2 books, and he covers things that aren't necessarily always covered with the books.
Right. So the next couple of bullets we can actually blow through pretty quickly. So I'm going to, Sandra, if you don't mind, I'm going to let you kind of dig through the book there, looking at security policies, and just talk through the next couple. Disabling unneeded network services, I mean, that's just a basic hygiene kind of thing. If you don't need the Apple file protocol running on your stuff, don't run that. Going through your switches, there's always going to be a command you can use to show, in Cisco Universe, it's typically show services, and you can see what's running. One of the things that is frequently turned on is LLDP. So LLDP is the link layer discovery protocol, and it's basically a protocol that hardware devices can use to interrogate one another and find out what they're what they are, how they're configured, that sort of thing. It's a very, very powerful tool if you are using it to administer your network, because you can use it to find out like how your switches are connected to each other physically without having to go and lay your hands on them. But if you're not using it, the guy or girl that's trying to break your network may be the one coming in to use it for you. So, Sandra, what's going on with the policies?
So in the book, at least, it's just like a page and a half, and it's talking about like corporate policies, like acceptable use policy, different network policies that could be, bring your own device policies. So it just touches on just the basic, what you would probably encounter.
Gotcha. Okay. So it's actual policy, not like,
Yeah.
okay. It, I won't conflate the issue with what it isn't. But yeah, I mean, I don't know if you guys have questions around that. I'm happy to talk you through the policy experience that I have. But I mean, that stuff is typically fairly straightforward, and
Heck, I think you spoke about it for almost at least 30 minutes when you came to ECPI. I still have that talk file.
yeah, policy was my life before in my last job. So if y'all have questions about the policy side of it, want to know or want to see some corporate policy, I'm quite certain I could scrounge up some example documentation to send your way. It's frankly the most boring thing in the world. If you need to get to sleep, crack it open. Yeah, okay, good. So secure protocols, are you guys familiar with all those protocols and what they do?
Familiar with them on a very elementary level. Like, I've read them a million times, but it's all been basically book level.
Okay.
I'm familiar with them and how most of them are used.
Right. So
I want to say I had to do something with SSH, and I could be entirely wrong in thinking of a different 3-letter acronym.
so we'll spend some time on this on Saturday.
Okay.
But so the idea, SSH is basically a secure replacement for Telnet. All right. SNMP version 3, it's a secure replacement for SNMP version 1 and 2. That one's the easy one. TLS SSL is it's a mechanism to encrypt traffic between hosts. The most common way it's used, and I would be willing to bet this is far and away the case, the most common way it's used is to encrypt HTTPS sessions, but that's not the only way you can use it. It's also used for VPN connections between like your workstation and corporate firewall or VPN gateway. A lot of them use TLS SSL or SSL TLS sessions. Now, here's the other thing to know about TLS SSL. The SSL piece is by and large deprecated. SSL is the old version of the protocol. TLS is the new stuff. So everybody uses them interchangeably. And I mean, I'm guilty of this too. I've been saying SSL for ages when I haven't been using SSL for the past 7 years. Like, we switched to TLS. So just keep that in mind, it's just an encryption protocol for encrypting network communication between hosts. SFTP, just the secure version of file transfer protocol. It adds a layer of encryption and it builds another layer of authentication so that's more secure. Traditional FTPs, and the ironic thing is that a lot of the networking gear doesn't support like SFTP natively. You have to like go and do things to it to make it use SFTP. That's one that I every place I've been, their networking gear doesn't use that universally. Like, it's just people forget to turn that on, and it is kind of a pain. HTTPS, that's just what Google's trying to do to the internet. And then IPsec, that is far and away the deepest well in this protocol list. IPsec is used for all manner of secure communications. You can enable it. It's a little more complicated to get going. It's a lot more complicated to get going than TLS SSL. But once you get it going, it's basically the best thing going for encryption between hosts. but it does in some cases require specialized hardware for certain key sizes and things like that. So, which I say specialized hardware, it required specialized hardware when I was learning about IPsec back some decade ago. So
Right.
it probably doesn't require, so the specialized hardware is now built into your Intel chip. What questions do you guys have around the secure protocols and why you would use them?
I don't have any at this point.
Crickets. Excellent. I'm going to accept crickets as a final answer. Access lists. Have you guys all dealt with access lists? Yes, no, maybe so.
It's is it a part of the router? It tells what
It can
it
be.
accepts and what it don't accept, or
It can be. So, understanding the way access lists work and how to read them is a pretty important skill that you're going to deal with at some point if you stay in IT long enough. In web content filter, so let me start from the beginning. Most access lists you just read from the top down, right? They are going to have a series of allow, 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 or deny, 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 and then they're going to flip it when you get to the end, and it's either going to deny everything or allow everything that didn't match everything above it. And there are various reasons for building access lists, various motivations for doing it. You can build them at the router level. Those tend to be much more. So, y'all are familiar with the OSI stack?
yes.
Layer 1 through 7. Well, routers are layer 3 devices, so their access lists are layer 3 access lists. They don't typically dive off into ports and like they won't let you filter out web traffic from this host. You're gonna route. Now there are some devices that allow you to do policy-based routing and things like that, where you can get into the higher levels of the OSI model to route traffic around. But typically, if you've got a device that's stuck at layer 3, it's gonna focus on the IP address, and that's it. Firewalls tend to be like layer 4 devices. They can get on up into port filtering, and all of your modern firewalls have started to do things like web content filtering and taking a deep dive into web sessions to look for malicious behavior, things like that. So the modern firewall, if you hear next gen firewall, that's just the fancy ass marketing term that says we've got a firewall that's almost layer 7 aware and is doing deep filtering based on that traffic that it sees to look at what it's actually doing instead of just looking at source, destination, and the port numbers involved. Which, that traditionally was what a firewall did. It looks at the source IP and port, the destination IP and port, and makes a decision based on its access list that says, is this traffic allowed? Is it not? If it is, it passes it. If it's not, it drops it. The implicit deny that it's talking about there is in most access lists. If you take a packet and you're going to run down this access list looking for a match, and you don't find a matching network in the source and destination, then it's just going to drop the traffic. It's not going to do anything with it. So does that make sense? You guys got questions around that?
Implicit just means that it's just implied. It just
says, it's implied. So even if it doesn't say it, if it doesn't match, it doesn't get passed. So even if you look at the access list and there's no rule that says deny this traffic, if there's not a rule somewhere that matches the traffic that you're trying to match, you just assume that the default action is denied. Now, every access list that I've ever seen will specifically say somewhere that it's either going to implicitly allow or implicitly deny the traffic. And that's typically, if it's not listed on screen with the access list, it's listed in the help information for the device.
Okay. So it depends on the model or brand that a device may be implied or implicit or implicit
Yes.
accept or.
I mean, implicit deny is way more common, but there are cases where an implicit allow is preferred.
Okay.
Most of that's on like most of that'll get into. It's probably best just not to worry about that. It's in like taps and things of that nature. So,
Okay.
Wireless security. So I'm not going to try to drag you kicking and screaming through those protocols because I don't know them well enough to do them justice. I know that WPA2 Enterprise is the preferred for every place I've ever worked because it's the best and the strongest of them. It's also the hardest to set up.
That's actually one of the big practice questions is which one is the preferred method?
Yeah, WPA2 is. And a company would be an enterprise version or
right. And the enterprise version typically gets you stuff like using certificates to authenticate both host and wireless access points. So the endpoint won't connect to the access point if the access point doesn't provide a certificate and vice versa. 802.1x is here it is. I'm going to add that to my list of things to do after this.
I think that's authentication one authorization.
Yeah, 802.1x is not just for it's not just for wireless. It's for authenticating endpoints prior to them connecting to your network, right? So basically, when you plug into a switch, the DHCP server gives you an IP address and then 4011 questions saying, hey, who are you? What are you doing here? Why are you on my network? TTLS. All right, that one I'm going to have to do some Googling on. Can't just rattle this all off the top of my head. I'm sorry.
All
Right. Just dock it from your pay.
Yeah, I'm going to have to do some reading on the TLS versus TTLS. It's been too damn long. And the MAC filtering, I mean, the MAC filtering is the MAC filtering. It's the same kind of switch port security. It's how crazy do you want to go? Or do you know that all of your company laptops have this kind of Broadcom MAC in them? Well, if you see anything that isn't that Broadcom MAC, don't let it connect. Now, that's assuming you want to strike some sort of balance between security and convenience and ease of administration. If you're going to be really hardcore, you'll just go and hard code all of the MAC addresses for all of your endpoints into your wireless access points and not let anything else connect. Problem with that is that MAC addresses are strong suggestions about which host you're talking to. There's no guarantee that somebody hasn't spoofed a MAC address. They're spoofable things. They're configurable on most hardware. So if all somebody's got to do if they want to connect to a wireless network that's using MAC filtering as its gateway to connecting is just sniff for MAC addresses that are there. When it sees one stop broadcasting because somebody went home or shut their laptop down or moved across the building to another AP, they just connect up with that MAC address and hey, look, they've got an IP address in their network. So it's easily bypassed security mechanism, and it's one of the reasons that I don't really like bothering with it because it's a shitload of work and not a whole lot of security. There are probably people that will argue with me though, so take that with a grain of salt or 12. And I'm going to call an audible on the user authentication protocols as well. Kerberos is where it's at by and large. I don't like using much else, but again, I'm not going to try to be better than your book at explaining what those protocols are. And the other thing to understand about these protocols is you're going to figure out how to, you're going to pick the one that's best. So you're going to select which ones provide you the best security that your user population will accept having to interface with, or that your organization can afford. And then you're going to configure it, and then you're never going to think about it again until it stops working, and then you're going to scratch your head and go, why the hell isn't this stuff magic?
Okay.
If you guys come up with questions on the authentication protocols, on the wireless security protocols, kick them over to me. I'm happy to answer them. But yeah, I'm not going to try to be better than a textbook on.
Yeah, it's a small amount of information on TTLS protocol that what it says is that it's a standard based and it's a tunneling method that it can work with PAP, CHAP, and MS-CHAP2. It supports mutual authentication and provides a secure tunnel for authenticating clients by using the EAP methods and other legacy protocols. So I guess it's just another way to help support older mutual authentication methods.
Yeah.
So I guess, okay, it increases security for these protocol authentication protocol types.
Right. Because I mean, basically what it's going to do is provide another layer of assurance that you're talking to who you think you're talking, or that your access point is talking to who it thinks it's talking to, and that the endpoint is talking to one of your access points and not something pretending to be that access point. Mm-hmm. But yeah, as for like the ins and outs of like specifically how it goes about doing that and the math behind it, sorry kids. Not this tutor.
It's okay.
What else you guys want to go through?
Well, we usually do a little question answer process that Sandra kind of sets up, which we go through and kind of answer find information on some of the questions when they come across. We don't kind of have a good grasp of it. We kind of go over it a little bit and go from there.
I can make test questions for this section for our next meetup. So if we have a little bit extra time, we can just go over it too.
Be great.
So 3.3 is the section you guys are going through this week, or was there more?
It's all of 3.
All of 3?
Yeah, the whole.
Well, did you want to go through any of the previous?
Let's see what was.
That's 2.7.
Oh, you're talking about here. Okay. I feel like I'm good here because it's just talking about compare and contrast these concepts.
Yeah.
Like, I've got the basic understanding. I guess blue snarfing. I've never heard of that. Blue jacket and blue snarfing. That just sounds
okay.
I read about that.
I've heard of most of these, but not.
I read about those.
These wireless ones. I've heard of Rogue AP, but I guess I gotta hit that for this.
Oh, that's cute. That's real cute.
What?
I didn't know what they were either, but it's Bluetooth.
Yeah.
Oh, that would.
Okay.
Okay.
It's cute. I like it.
424.
What is? What's next? Oh, it's bypassing protections on the device to. So blue snarfing is just collecting data from the device. Like if you connect to a phone, rip in calendars, contact lists, emails, text messages, that sort of thing.
Oh, okay.
It's the reason you turn your Bluetooth off. Huh, cool. Didn't know there were specific terms for those, but awesome.
Yeah. I mean, I do it because I feel like it saves battery. So if I'm
Oh,
not
it absolutely does.
Bluetooth, so I guess there's an added reason why to do it.
Oh yeah, yeah.
I thought you had to accept the connection with
If the
Bluetooth.
security on your device is good, yeah, you do. But if the security on your device is not so good,
So yeah, that's the thing that gets me is how do they access it without unless something pops up and make you say, hey, I'm gonna accept you because you popped up on my phone and yeah, I like it or whatever. I don't know. I just don't get that how they.
so there were. I mean, in older Bluetooth devices, there were memory corruption bugs where, so there's a protocol, right, for exchanging information when you do your handshake to decide to connect to one another.
Mm-hmm.
There were protocol bugs where the device, you would pass it, it would be expecting a certain amount of data, and you could feed it just a whole lot, an arbitrary amount more than that, and it would just start processing the rest as instructions in memory, right? So you feed it a request, hey, can I connect to you? And oh, by the way, send me all of your contacts, and it would just do it. And then it would reject your connection attempt because it didn't want to connect to you, but it also would respond to your other request for all of the contacts. I mean, stuff like that where it's memory overflow and then there, I mean, if you want to waste a weekend, you've got a long one. You can spend it looking at the history of security in the Bluetooth universe, and it's god awful. Like most device security, it's just terrible, and it never changes.
Well, they got a little note here that says the Bluetooth standard has addressed weaknesses in the technology, and it continues to get more secure. One of the simplest way to secure the Bluetooth device is to not set their attribute to discoverable in the device setting.
Right. The discoverable in Bluetooth basically when somebody sends out a broadcast and says, hey, is there a Bluetooth device around? If it's discoverable, it'll respond. If it's not, it won't. So it just makes it not quite as chirpy. But there are psychotic ways to go in and like poke at devices and make them respond, even though they're not set to discoverable. But that's a level of witchcraft that I'm not.
Does it just mean that you turn it on that makes it discoverable?
No, if you go like in your iPhone, you can enable your Bluetooth, but then you can also make yourself discoverable. And typically to pair with another phone to transfer files, you have to become discoverable, right? But if you want to sync photos between your phone and a device over Bluetooth, that's typically the way it does. Ralph, somebody that knows more than I do, here to save the day.
The NSF or NFS process. You know what I mean?
NFS process?
Yeah, is that like the NCF, or I hope I'm saying it right? Like when you have two phones, you have that on, and if they're right next to each other, it'll pass data between the two.
Oh, the near field communication stuff?
NFC. Oh, that's what it is, NFC.
Yeah.
Is that part of the discoverability of it that you're referring to?
Honestly, don't know.
Okay.
I thought NFC was a separate thing that didn't necessarily need Bluetooth. Ralph, save me. It's your giant brain. He's ignoring me. Yeah, no. The near field communication is a separate competing protocol. I was thinking it was.
Does it work on the Bluetooth technology though? I mean,
no, I don't think so. I think it's a totally separate platform. It may use the same radio in your device, but and apparently you can pair Bluetooth devices with NFC devices. Like I said, this is some black magic and witchcraft that I am not terribly well versed in.
Okay.
I'd be happy to do some research with you though, because it's interesting.
Okay.
VLAN hopping.
I think the only other thing on here that I'm not familiar with is that very last thing, that Tempest RF emanation. I don't even see that in my book.
Which one?
It's that third column, bottom, 3.2.
Oh, Tempest RF. Some radio frequency.
Oh God, I have to share this. It's in Comic Sans. I can't not share it. Someone else must suffer with me.
Oh, and it's from Sans.
It's from Sans. In Comic Sans. Oh God, why? Why did you do this? So my reading of this is that if these guys are your adversaries, you're out of my league. So
Oh, that's Comic Sans.
it is Comic Sans. It's Comic Sans all the way down.
Hey guys, I'm here. What you guys talking about?
Oh, I'm just bullshitting.
I hear you there.
We were going over basically this, and we got through, let's see, a good portion of this. Adam said he wanted to skip wireless. His forte. And I don't think we covered hashes. And then there were some topics. We're gonna meet again next weekend, not this coming weekend, but the following one, and go over VLANs more in depth, secure protocols, and more hands-on with that. If we can meet physically, then we'll probably do that. If not, Adam's gonna set up something virtually to where he can show. And that's pretty much it. We're going through some of these things that we don't know about. Like right now, we didn't know what this was. It wasn't in any of the books I had, and then Adam found this, and he was talking about it being in Comic Sans font.
Yeah, and today, basically everything needs shielded because of near field communication, RFC, and a lot of our devices kind of being used. Like I know, for example, here for what's the subset? So NFC is used for a lot of payment systems today, and so a lot of your credit cards will come with the ability, or even just cards in general, they'll have the ability to kind of use that as contactless payment. So you'll have to buy, like even on Amazon, if you look, there's a lot of wallets you can get that have shielding around them.
Oh, okay. Yeah, because I think I had that for like my passport and stuff. The
Mm-hmm.
anti RFID and stuff like that. Okay.
Yeah, so that's what that is. Near field communications is a high range RFID, I think. So, but it's used a lot more for those types of things like contactless payments and stuff like that.
Okay.
But you need to know Tempest and you need to know Faraday cage in general, because both of those are two types of, I guess, techniques to try to limit that data exposure. And then also things like white noise too. There's lots of different techniques out there that are trying to control the emissions of information. Even white noise is used more for trying to disrupt people trying to eavesdrop on your conversations and stuff. But you know, from a data sense, Tempest and Faraday cages are used for emissions.
Okay. Yeah, I can thank Mythbusters for the Faraday cage reference.
Mm-hmm.
Okay.
What was that site again?
What was just up?
That
It's in the chat. Adam put the link there, and then I'm gonna copy it and put it in the notes document.
Yeah, here's the difference. This is the link for the difference between near field and RFID, in case y'all need that.
Okay. Okay, I'll just update that in our notes. Let's see. I guess technically, like the idea of the Faraday cage could fall underneath here. Physical security control, maybe.
Yeah. Have you guys ever, you probably have been to a room before and wondered why you really didn't have a good cell signal?
Mm-hmm.
You know, that's the focus of something like that, is it's trying to control the data from leaving.
I mean, I've been in places where you couldn't bring a cell phone in, but otherwise it was just pure coincidence of not being able to use my cell phone.
Yeah. So like I've been in a building before where they had special tint on a window, and the whole focus of it was to try to keep the Wi-Fi signal and keep a lot of the signals in that area contained. So that's kind of the concept, is with that, you don't want any of your signal leaking out, is the whole purpose behind Tempest and the whole purpose behind Faraday cages and things like in a forensics investigation, you get these things, Paraben Forensics makes, called, I'll have to look it up, but that's what they do. You would collect any kind of wireless, I think they're called stronghold bags, but you would put those wireless devices in the stronghold bag so somebody couldn't send a kill signal to that device from a remote location and try to wipe it.
So, curious question, because I know at Blue Cross where I work, they do not allow wireless and they do not allow hotspots. And apparently, if like say, you know, on my phone, if I put up my hotspot, they have the ability to see that and eventually they could come in and find me, is what they say.
That's right.
I just think that's kind of interesting. Like, is it so? How would that be set up when you have, you know, several buildings with several floors?
Mhm.
Is that all built into the network as like a separate thing?
No, so basically the way this works is it's usually kind of an IDS is what we're looking at here, like a wireless IDS or a wireless IPS or something like that. And the way it's set up is it has a known good connotation of that area. And so if I deploy a sensor and I've got a bunch of Wi-Fi access points around there, I know what their MAC addresses are. And your device, if it's given out like a hotspot, it's got a MAC address too. So it looks at and compares what is known, which is basically what's supposed to be there, and finds that you are trying to do something that is like a rogue access point. If you've heard of that kind of concept, you're trying to do that. They detect that, and then they can GPS locate that position where it is based off the sensors that are analyzing the Wi-Fi signal around you.
Because they said they could, even in the parking lot, if we do a hotspot, that could be, you know, no/grounds for termination.
Yeah, I mean, and the only, you know, really the only way that they can back that up is through a policy. You work there, so you have to agree to that policy, because that wouldn't stop somebody off the street that would come by Blue Cross and park in the parking lot and do that. Now, you know, I don't know, it might be because it's Wi-Fi. You can't, I don't know, again, I don't know enough. Maybe there is rules against that, but I've never heard of Wi-Fi trespassing before. But
yeah.
That's
Yeah,
interesting.
the policy, I did have to, you know, it's one of the things you sign off on as a new hire.
yeah,
But yeah, we have to remind sometimes when we have outside vendors, and they're like, "Can't you just do a hotspot?" No.
yeah. And it's just a control measure.
Mm-hmm. Yeah, we have a lot of contracts that are kind of important, so that's just one of the things that they agree to. Okay, I think I'm good on physical security controls. I mean, I pretty much have encountered all of these except maybe man traps.
Yeah, man traps you would see at Blue Cross. I know they have them in the data center area. It's typically used as a way to deter any kind of people slipping in to a place of sensitivity that they are not supposed to be. So usually they have 2 doors. Sometimes they'll have just a CCTV monitoring access. Sometimes there'll be a security guard there. The inside door doesn't. Yeah, the inside door won't open unless the outside door is closed. Some of them have pressure sensitive flooring, so they know how much, who's in the room, basically.
Okay.
That's fancy stuff.
Yeah.
Yeah, I always encourage, because I teach new hire, I always encourage people, especially if they're working in the IT fields, if they're not working in the data center, to get a tour, because it is like freaking like 007 up in there. And it's multiple floors too. But I think I'm good on that, unless anybody else has any questions.
I'm good.
Yeah, Stella was on that tour. We had one of our classmates worked in the data center and was able to get us in for a tour. I mean, I guess theoretically, if we wanted to do that as a COLASEC group, we could set that up. I still have the contact. kind of sidebar FYI. Let's see. I think I'm good on the firewall stuff. Does anybody have questions?
Nope.
I think like the setting techniques, some of that will be covered in some of the stuff Adam said he would talk about, but
Which
this middle column, because you kind of covered some of it already, like
yeah. So the ACL stuff is easy enough. The virtual wire versus routed is not going to be something we can cover terribly easily. So excuse me. The cleanest way to think about that virtual wire versus routed is basically what state the firewall's going to behave in. Most of the firewall applications that I've dealt with have been routed. And I mean, I don't know if you have any information on this, Ralph, but I would imagine that that's the vast majority of firewalls. And all routed means is that the firewall is sitting there acting as a router in your network. So it's got networks off of it that it can route traffic between, and it's going to receive traffic on one side and pass it out the other as appropriate. Virtual wire is different in that it won't do that. It is purely going to take traffic that comes in at one interface and pass it out the other, or it's going to drop the traffic, or it's going to send resets, whatever, based on the configuration of the firewall. And there are different reasons for implementing firewalls that way. You can sort of soft roll into deploying a new firewall. If you put it in virtual wire mode downstream of an existing firewall, you can kind of start to build out the rule set and slowly migrate away rather than try to forklift the whole thing. Are y'all familiar with the DMZ and what that is?
Yes. It's the point where I guess the service provider meets where your device.
So sounds like you're talking about a demarcation point. That's a slightly different concept than a DMZ. So
okay. Okay.
A demarcation point is basically where a service provider is going to bring in their circuit, hook up their equipment, and then you've got to plug into it and take the service they're providing you on to the rest of your network. A DMZ is a demilitarized zone, is basically a point in your network that you cordon off the things that are publicly facing. So you're going to take all of your web servers, you might put your mail server out there, you might just put your email security platform out there. But anything that's sort of outwardly facing that someone could get their hooks into from outside your network, you put in a DMZ, and then you put a firewall between that DMZ and the rest of your network. Now, let's see if I can pull up a... I am not going to find a diagram that demonstrates what I'm talking about. So there's a couple of different ways you can do DMZs. You can do a DMZ, actually, I just found what I'm looking for.
see, I have one in my book.
Well, so there are, that's one implementation, which is...
Now, I have a question. Is a DMZ physical, or is it like virtual, or can it be both?
The answer to all of your questions is it depends.
Okay.
So typically a I mean, there's going to be some sort of physical component to it, right? But not necessarily. You could do a DMZ purely out of a VLAN, and the only way it can communicate with the rest of your network is over a routed port which connects to a firewall and funnel the traffic that way. You could also have physical servers that are plugged into a physical switch that connects to a physical firewall port, or so that was what I was talking about, the couple of different implementations. The three-legged firewall, I did send a three-legged, right? Yes, diagram 2. So the three-legged firewall is what I've dealt with most often, and that's basically just where you've got a single device that's acting as a router. One of its interfaces is your DMZ, and one of the interfaces is the internal network, and one of the interfaces is the internet. And then it can route traffic between all three places, but it's sort of a simpler design to understand. Cisco's textbooks also loved to, when they talk about a DMZ, and I think they did this as a sales tactic, talk about this double firewall implementation, which is the other image that I linked. And basically the way that works is you've got a switch network parked between two firewalls, and you've got a firewall upstream on the outside edge, and then you got a firewall inside on the inside edge, and then the DMZ is the space in between where you would have the servers that need to be publicly facing. But the whole idea behind it is that there is a firewall, a network firewall, sitting between those things that have to be publicly facing and those things that do not have to be publicly facing. It gives you an edge to defend. So can we flip back to the other thing?
This one? Or
I was going to say, go back to the book, unless y'all have questions about the DMZ and like why you would want one.
that makes sense why you would want one.
Yeah. ACLs we can spend a little time on next Saturday. Oh, that isn't interesting. The inbound versus outbound. Other words you may see for this is ingress versus egress, and egress is just outbound. Ingress is just inbound. So one of the things you have to do when you're troubleshooting networking issues and when you're configuring equipment is to consider the direction of traffic flow, and not just the traffic doesn't just flow in one direction, right? For a website to come up, you're going to have hundreds of bidirectional communications that go back and forth between the client and server before that website loads. So you have to consider both directions of traffic flow and make sure that everything matches and jives. And it's one of the things you have to wrap your brain around, is the way traffic's going to move within your organization. And I could go into a little more detail about how that might go wrong on Saturday. I can prepare a network diagram because I've got an old one that I can show you where things did go wrong. Questions?
No question.
Ralph's not spending nearly enough energy calling bullshit on everything coming out of my mouth.
I think we are a little too early in our growth here to be doing that.
Ralph is totally capable.
Yeah, so just for the test on firewalls, you really just need to know a couple things. You hit most of them, Adam, but big things about the DMZ for sure. I know for the Network Plus, it's going to want you to know the network, or excuse me, the DMZ that's between two firewalls, one external, one more internal, and so that you can allow traffic in more graciously into the DMZ from the outside firewall, and then be more strict in your allowing access to the more internal trusted network. So that's the one for at least the test that they want you to do, is the two firewall setup. Sometimes they call it I think they call it like a multi-home firewall or something like that. But another term they use for DMZ as well is called a screened subnet.
Okay, those are details I could not have provided. Yeah, I can spend a little bit of time putting together a network diagram and some example ACLs on how that might work. So we'll go through that on Saturday while we're actually looking at networking equipment.
So how would you have a screened subnet at home? Oh, yeah, I was trying to grasp that because the equipment most people use isn't, separated in layers, I guess.
So it's not, but I mean, if you've got a router at home, you've got a firewall, right? It's got it's I wouldn't want to run a business off of it, but it's a firewall. But there are also open source alternatives, so you can run open source firewalls.
Oh, okay, because it could be software or hardware, is what you're
right.
saying?
But
Okay.
I mean, you can also take a Linksys firewall and flash an open source firewall onto it, and then you basically have pfSense running on a Linksys router.
Linksys.
So that edge firewall router I just sent you guys is amazing. So basically, it's rather inexpensive. I think the device itself is like less than $100, but each port on there is an isolated port. So, and this is kind of interesting because I'm doing a lot of IoT stuff now. And so I'm wanting to use something like this so that eventually in the future, what you're going to see in homes is you're going to see people isolating their IoT kind of junk crapware and put that on an entire separate segment for your internet connection than you would more your trusted assets. So you can definitely get it. And I'll also put a link to another real inexpensive, well, not, I mean, compared to enterprise cost, but pfSense, you can actually buy a pfSense firewall, put it right next to your modem, and it has a lot of capabilities to do some of that isolation stuff.
Yeah. And to your point about so one of the uses for VLANs, Ralph was talking about having a separate segment for your Internet of Crap things. You could theoretically build a VLAN for each and every Internet of Thing device in your house, and then only allow them to talk to one another if you really wanted them to talk to one another. So your washing machine can't start having conversations with your light bulbs, and I don't even know why this is a thing. This is just such a hellish place we found ourselves.
Yeah, I know.
But the capability will be there to prevent them from talking.
You build a home network, you can put something like that in, and you can create ports throughout different areas of your home, wired or wireless, using this. Okay. Ralph, I see a link you have on here for Google Drive. Is it something we got to request access for?
Don't know. I thought I gave it to everybody. I don't know. Let me see.
I just clicked a link to request access.
You say
Let
you
me
need
see.
permission.
I might need to change it. Oh yeah, you're right. I'm sorry. I didn't change it. Hold on a second. All right. That should do it right there.
Okay.
Beautiful.
Okay. Great.
Yes.
Oh, this is another book. Okay. Okay, great. Okay. DMZ. Could you use this router, like if you want to set up your own home security, like network, using IP addresses and things like that, so you can see what's going on around your house even when you're not there, stuff like that?
I caught the tail end of that. I'm sorry. What?
Okay, the Edge router, the website you showed us, is that something you can use to set up cameras around your house that you could use to, like, use the IP address to look in on it on your home in different areas wherever you got cameras?
Yeah, sure. There's no reason you couldn't. I mean, you can also. So.
Sorry, I got stuck, guys. I was trying to do something else there. Yeah, you can. Well, I don't know about the Edge router because I don't have that one, but I have heard a lot of people talk about that to be able to isolate. But the pfSense, it's just a regular firewall connected to the internet. So if you wanted to, set up an app, if the app supported, connectivity over the internet somehow, I'm sure you could probably do something like that.
Well, and the other thing you can do, so if you start to, but it depends on the system, right? If you're going to dump 14 or 15 things in your network, you're going to run out of ports. But one thing to look into if you're into that is small business class switches. It's basically all of the robustness of a full-on like $4,000 switch. It's in a smaller price point. And it can't do everything, but if you get a managed one, it can do a lot of the like VLANing stuff that you'd want it to do. And you can, it allows you to play with things like that, where you could throw dozens of different devices on their own little micro subnets and then analyze which ones are talking to which and all that.
Be interesting to do. You get a better feel of the process at home, when you don't get the opportunity somewhere else,
Yeah, I mean, straight out of the box, if you can get pfSense loaded onto any kind of home router, it will give you the capability to go through and look at the traffic between nodes and start slicing and dicing and see which ones are talking to which and all that. I think you'll be stunned at how chatty most of your networking gear is. Most everything that I've ever seen on a home network just loves talking to everything else, just to see what's out there. Because like a lot of the home theater stuff is real bad about it because they all want to talk to one another, so they can start, I guess, in theory, allowing you to stream to different things. But I've not had a whole lot of success for all of the chatting that I've seen them doing. So anyway, what else shall we cover?
Does anybody see anything else they want to go? I'll go back up to the top. In case we missed anything.
That other document I sent has some examples of setting up access control lists in case you guys want to read that.
This one? Or another one you just sent?
The second one? Or the last one?
This one?
Yeah, that's the one. A little bit lower down, they have what the configurations look like. I did notice that on the NetPlus, they are starting to put configurations in some of the questions, or at least some of the text as well. So it's good to kind of see if you can read some of what is being configured there. It's mostly Cisco, so don't concentrate on any other. I wouldn't, but definitely the more you can read that stuff, the easier it'll be.
Configuring a firewall.
Anybody have any other questions in the color? Can we touch on hashes? I don't think we touched on that. Let's see what it's got in the book.
Hashes are black magic. So, hashes are one-way mathematical functions that generate typically fixed-sized output. So no matter how much data you pump into the front end, it's always going to give you a fixed amount of data on the back end, right? So what that's useful for is you take a whole big string of data, you change and you dump it in, you're going to get a hash. You change one letter, you dump it in, the hash should change completely, be a totally different hash. So it's got tons of applications in security protocols for analyzing your data to make sure that it hasn't been tampered with. It also has uses in looking at packets to make sure that the error rate, or that the packet was transmitted successfully and wasn't tampered with, things like that. So MD5 is an old hashing algorithm. SHA is a newer hashing algorithm. SHA-1 has been deprecated. Part of the reason that these protocols have been, the reason we don't use MD5 anymore is because collision started to be a really easy thing to produce. And the collision is simply so I have this set of data that produces this hash output. Well, what other set of input can I feed to this that gives me the same output? And more specifically, can I engineer this data that does something that I want such that it gives the same hash as this other file that I want to pretend to be? So because of those collisions, and they're easier to calculate now, the protocol's been deprecated because it's not providing the same level of protection and assurance it was before. SHA-1 has just gone through the same thing, and then
Yeah, I don't see SHA at all in my book. I see MD5 though.
Right. Well, and if you're going to get into the black magic of how that's calculated, that's over my head. That's math that I wanted to understand and gave up on.
Then I'll probably not even say because I don't like math.
Ralph, can you is SHA-2 collisions a thing now?
Yeah, here's the thing. So this is just my opinion on it. I still see MD5 used for passwords. So
yeah.
Yeah. So
Sure.
This is the downside of things. But anyway, yeah, SHA-1, they just here recently were able to carry out that in a example collision attack. So the next step up for us is to start going into SHA-256 or SHA-512 and some of these other hashing algorithms For the test, though, there, as you can see right there, they're going to focus on still MD5 and SHA. Now, both of those are still used for message integrity. So it's not that they're so much broken, I guess, for the integrity purpose, even though that can kind of come to question depending on how sensitive the data is. But passwords was the big problem, where application developers were creating as an authentication mechanism. They would use something like digest authentication that was using MD5, and that's not good enough anymore. So it's real easy to crack passwords that use MD5. So that's, again, it's not safe to use that for more sensitive types of transactions. But everything else you said there sound fine. They might expect you to know like numbers. And so like for MD5, it's 128 bit, and SHA-1 is a 160 bit. So the thing about crypto in general, no matter if it's used for confidentiality or integrity or whatever, in the case of confidentiality though, the larger the value, the larger the work factor, which means basically I can create more entropy in the actual process and make things more complex, which is always a good thing anytime it comes to cryptography. So do keep that in mind as well.
And this may be less relevant for your test, but part of the SHA is a completely different like method for arriving at that hash value. There were fundamental problems from a cryptographic standpoint with MD5 that prevented that algorithm from just scaling up. So SHA, you can scale up from 160 to 256 bits, and you get orders of magnitude more work. And that it didn't scale as well with MD5, where you could increase the amount of work you had to do on the front end, but it didn't apply as cleanly. You were doing a lot more work for a lot less gain. That is getting into the black magic that I wish I understood better. But anyway.
I feel like we're finding topics for people to speak at CoLSEC, future CoLSEC meetings. All right. I think we covered everything for this section, minus what we're gonna cover for next weekend. So say we all.
That sounds good to me.
Stella, are you good? Okay.
And I'm kind of ashamed of myself. I should have said so say we all. Not nerd enough.
All right. Well, thank you, Adam and Ralph, for joining us. I think this is pretty successful. And then being able to volunteer for next weekend, we are in your debt. Once again.
Tony.
With that, I guess we will end our little group. I will grab all Ralph's links and plop them into the Word doc and upload that along with our broadcast link as usual.
Okay. And I'll send out something on VLANing and a example config from a switch so we can look at it, talk about it, and dig into it.
Awesome.
Cool.
Thank you.
Yep.
Sounds
Y'all
good.
take care.
See you later.
All right.